Okay, what do we have here? We have two signals being displayed from two independent function generators. This trace here is the trace coming from the Interstate F43, and it's set to produce a positive and negative going square wave, and the B probe is set to 0.1, and with the 10x probe that means it's 1 volt per division. So we have the center line right exactly in the center of the screen, that's 0 volts, focus. And then we have 1, 2, 1, 2, 4 volts peak to peak, plus 2 volts, minus 2 volts. Okay, and that's from the Interstate F43. I'll vary the frequency here so you can see that that is in fact where that trace is coming from. Okay, now the bottom trace here is coming from the WaveTek Model III over there, okay, and it's also set, I have it set to produce a sine wave output, and its trace is being shown here at 20 volts per division. It's a 10x attenuated probe, and I've got it at 1 full division, so that's a 20 volt peak to peak sine wave oscillation there. Okay, 20 volts peak to peak coming from the WaveTek, and I'll vary its frequency to show that, sure enough, that's where that's coming from. Now we're triggering on this trace, and since the two oscillators are unrelated, this trace is moving. It's not stopped, but this one is because we're triggering on it. Okay? So those are the two traces being shown on the oscilloscope. We have a 20 volt peak-to-peak trace here and a 4 volt peak-to-peak trace here, going from 0 to +2, 0 to -2, right? Okay, so what I'm going to do now is I'm going to disconnect the A probe from the WaveTek. Like that, okay. Right. Now I'm going to take the B probe and move it from that function generator lead, positive lead, over to the WaveTek function generator, positive. I can get it in there. Ouch. Come on, you. Alright. Now I'm going to take my little jumper here, and I'm going to use it to put the two function generators in strict series. I'm taking the positive lead from the Interstate and hooking it to the negative lead of the WaveTek, and so they're in series. And then I'm looking at the total signal with them in series on the oscilloscope. Now what's happened here? Bazoom, okay. So let's do some attenuation here. Oh, sorry. Let's attenuate the signal from the WaveTek down to something more reasonable. Alright. So do you see what's going on here? We put the function generators in series, and at first the WaveTek's signal was incredibly high, because after all we're looking at that signal at 1 volt per division, and the WaveTek was putting out a 20 volt peak to peak signal. Now I've attenuated the WaveTek signal somewhat, and you can see that the signal from the WaveTek is superimposed upon the signal from the F43. Here, I'll vary, if I can get it to focus, I'll vary the WaveTek's frequency from something really high to something really low. Okay, and now I'll vary the Interstate's frequency. Okay, so the signal from the WaveTek, even if it's really large, I'm turning up the amplitude, if it's really large, it's still superimposed on the much lower voltage signal from the WaveTek. I mean, from the Interstate, right? So if I turn up the excuse me, allergies. If I turn up the WaveTek signal really high and then change the amplifier setting, what happens is I don't know if I can catch that or not. Since we're trying to trigger on the Interstate, it's kind of hard. Let's see here. All right, with all those oscillations on there, it's very difficult to get the scope to trigger properly. Anyhow, I do hope that this little demonstration has at least convinced you that a signal, an oscillating signal of high voltage, relatively high voltage, like that, can indeed be passed through the function generator, and of course if we were powering a load, the load would see it too. So this is two function generators in series, one of them with a lower voltage peak passing switching a low frequency, and the other one with a much higher voltage peak to peak being sent through it with frequencies, slow frequencies, fast frequencies. All right. Thank you for watching.